All right, so this is an example of Darcy's law. So let's start with this thing called the hydraulic gradient, which is the height um, of some body of water minus the height of the other body of water divided by the distance between them. All right, so we're going to calculate the the hydraulic gradient. Let's get some numbers. All right, so if we go to the textbook, there's an example of this right here. All right, so this is the full. By the way, this is the full thing that we're going to do. Um, the groundwater flow rate. That's really what we're looking for. And so what we're about to do is this part right here, the hydraulic gradient. So the other stuff, the hydraulic conductivity and multiplied by the cross-sectional area, multiplied by the hydraulic gradient. These first two, the hydraulic conductivity and the cross-sectional area, are always given to you. All right, so here let's look down here at the problem. Consider an aquifer that has a length of 10 kilometers and is between two lakes, measuring the perpendicular to the length. A vertical slice of the aquifer has a cross-sectional area of 200,000 square meters, right? So that's the cross-sectional area. They just gave us that number, right? And then the elevation of the water surfaces. The surface at Lake A is 215 meters above sea level. You always have to have a reference. The typical one is to use the reference above sea level, and then the second lake, Lake B, has a height of 210 meters above sea level, right? And then so we know the distance between the lakes, or the distance between the aquifers, which is underneath the lakes. Anyhow, we know the difference in height, or what we can calculate the difference in height, and then the last little bit of information, we need to know what the hydraulic conductivity is through the aquifer. And so that they're saying here, so they're giving us that number. That's this number right here. The hydraulic conductivity is 10 meters per day. All right, so the groundwater flow rate will be so many cubic meters per day. So what volume of water is going to move per day. All right, so that's ultimately what we're trying to show. All right, so again, it was so 215 and 210. Let's try to remember that. 215 and 210. So that's my A and B. All right, so here, let's write this down. So this is equal to 215 meters minus 210 meters. And you might remember the distance between the two. Here, we can go back to the picture real quick, just to see it. Oops, wrong thing. The distance between the two is 10 kilometers. All right, so right away that's a problem. So you see, you can't, you have to have this distance right here has to be in the same units. All right, so we know that it's 10 kilometers. That's fine. But since the heights are in meters, it's just easier to change this into meters. All right, so, and of course the way that we do that is with the metric prefixes. The K stands for times 10. All right, so that's another way of writing that is E3. So it's basically 10,000 meters. All right, so this is actually what goes in the denominator. You got to make sure the units are all the same, because this thing called the hydraulic gradient is a unitless number. So the units, the units of meters, have to cancel. So what I'm going to put in the denominator is 10,000, or 10 times 10 to the third, which is 10,000, of course, meters. All right, and then now the meters will all cancel. Okay, so then here, so we get our calculator out. So this is a really small number, very, very small number. All right, let's see. able to see that calculator right now. All right, so so it's 215. Let's say 250. So, you know, it's 5 meters, right? 215 minus 210, right? 5 meters divided by 10,000. So that's going to be a really small number divided by 10,000. Or, you know, it's 10 times 10 to the, you just hit the exp to the third. That's the same thing as typing 10,000. All right, and so that's the answer. So that's our hydraulic gradient. All right, and that's actually the answer to part A of the overall problem. Right, so this is equal to 0.00. Let's see how many. I lost my calculator. So 0.0005. All right, 0.5. Right, so that's the hydraulic gradient. So you'd put that in for the number. All right, and then to finish up Darcy's law, so now all we're doing is we're going to multiply that 0.005. So this is what we just figured out, the hydraulic gradient. Multiply it by the two numbers that are given, the hydraulic conductivity, which is 10 meters per day, times the cross-sectional area, which in this particular case is 20,000 square meters. Okay, so I'm sorry, 200,000. Sorry about that. So let's 200,000 and 10 meters per day. All right, so here we go. All right, so 200,000. So this is 200,000, and of course that's square meters times 10 meters per day. Right, that's the hydraulic. All right. Anyhow, so then we multiply that times 0.0005, right, which we just figured out. See, this hydraulic gradient, is the thing that you'll have to calculate, right? Just given the difference in height and the distance between the two. All right, so that's the thing, and these numbers here are given to us. All right, so anyhow, that's still in my calculator. So let me get that calculator. Oops, let me move it so you can see what I'm doing. All right, so there's the 0.005. I'm going to multiply that times 10, and then I'm going to multiply that times. But I don't know what I just did. I just did something wrong. I wasn't looking. Sorry. So it's 0.0005 times. Hold on. Gotta get rid of this. Sorry about that. 0.0005. All right, so that's that number times 10. Oh, I must have hit some other buttons. Times 10, and then times 200,000. All right, so 200, and then 1,000. 1, 2, 3. All right, so there we go. And so that this is remember what we're going to calculate, what's called the groundwater flow rate, and the answer. So let's go ahead and do that. Oops, where's my calculator? There it is. So once I hit equals, that'll give me the groundwater flow rate. All right, and so that's what it is. All right, so this is I'll write it out here. We've solved Darcy's law. Groundwater flow rate. So sorry, it's hard to write this on my computer. So the groundwater flow rate, and we just look at our calculation. So it's 1,000. All right, and what are the units? Okay, so look, you can actually see it right here. So it's 1,000 meters squared times meters, right? So that it's 1,000 cubic meters every single day. All right, so 1,000. So here, let's just write this out. 1,000 meters cubed, right? Because you got meters squared times meters per day. So that's the proper units of the groundwater flow rate. All right, so there's an example, a full example of Darcy's law. make sure you know how to do this. All right, very good. Where's my? I'm going to stop this.